is elementary combinatorics chapter. This is for second year MFCS. First topic is principle of inclusion and exclusion for two sets. Let us suppose take A comma B are two sets. Then the principle of inclusion and exclusion for two sets is mod A union B equals to mod A plus mod B minus mod A intersection B. Now Venn diagram for two sets. These are two sets A and B. This is A intersection B. This is A minus B. This is B minus A. In the same way, we have principle of inclusion and exclusion for three sets. So A comma B comma C are three sets. Then mod A union B union C equals to mod A plus mod B plus mod C minus mod A intersection B minus mod A intersection C minus mod B intersection C plus A intersection mod A intersection B intersection C. Okay. Now coming to the problems. First problem is a company requires a computer company requires 30 programmers to handle system programming jobs and 40 programmers for application programming. So company requires two types of jobs. How many types of jobs? Two types. So first one is system programming and second one is application programming. So for system programming, he needs 30 programmers, and for application programming, the company needs 40 programmers. Suppose the company appoints 55 programmers. Company is recruiting 55 programmers to carry out these jobs. That means these 55 can do either of these two jobs or both can do. Okay, either the person can do only system programming jobs or that person can do 40 programmers job, application programming job, or that person can do both. So like that the company appoints 55 members. How many, now question is, how many of these perform jobs of both the types? In these 55, how many can do both the jobs? Okay. How many can do only system programming job? How many can do only application programming job? They are asking. So now, how many types of jobs the company requires? The company requires two types of jobs. First one is system programming. Second one is application programming. So I am taking, let A be the set. Let A be the set of system programming. Let A be the set of system programmings. System programs. That is mod A equals to how many system programmers they need? 30. Let be the set of application programming. Let be the set of application programmers. That is mod B equals to 40 members. Okay, the company requires the company appoints 55 programmers. So the company is recruiting 55 programmers to carry out these jobs. That means 55 programmers can do either A job or B job or both. This 55 can do either A or B or both. That means that is nothing but A union B. The company appoints programmers to carry out the two types of jobs. Two jobs equals to 55. That is mod A union B equals to 55. Okay. So now what the question is asking, how many of these perform jobs of both the types? How many of these perform both the types? Both the types means that person can handle A as well as can handle B. Okay, so that means first answer, how many of these how many of these perform jobs of both the types. Jobs of both the types. That is mod A intersection B we have to calculate. Okay. Since we know that by the principle of inclusion and exclusion of two sets, since we know that mod A union B equals to mod A plus mod B minus mod A intersection B. Here we have to calculate A intersection B. A union B value we got mod A value we have and mod B value we have. What is mod A union B? What is mod A union B? 55 equals to mod A 30 plus mod B 40 minus mod A intersection B. So this implies mod A intersection B equals to 30 plus 40 minus 55. So we get 70 minus 55, we get 15. So mod A intersection B equals to 15. Therefore, 15 programmers can perform both the types of jobs. 15 programmers can perform both types of jobs. Okay. Now first bit is completed. Second bit is, what is the second bit? How many handle only system? How many handle only system? Handle only system programming. Only system programming. For suppose I'm going to explain through Venn diagram. Suppose this is the system programming. Now this is application programming. Okay, A intersection B we got. What is A intersection B? 15. Now how many handle? This is system programming. This is application programming. Okay, in this set, in the system programming, some people can do application programming also. In the set A, some people can do application, but here asking the question is how many handle only system programming? Only system programming, and only A we want. Only A. Suppose now this is total, this is A union B. Okay, this is A union B. This is A intersection B. Only A means, that is only A equals to A minus A intersection B. Okay, this is A. I want only this one. Only A means A minus B. Only A means A minus B. A minus B. But how can we calculate this? How can we calculate this only A? This is A. This is A. From the A, subtract A intersection B. We get this one. Okay. So that is mod A minus mod A intersection B. From the set A, subtract A intersection B. We get only A. Okay. So only A equals to, what is mod A? 30. What is mod A intersection B? 50. So we get 15. So only system programmings perform, only system programmers are equals to 15. Now next, third bit, only application programming. Only application. Only, how many handle only application programmers? See, same by Venn diagram. This is A, this is B, this is A, this is B. Now I want this only. I want this is. So this is B. From B, subtract A intersection B. Okay. So only B, that is only B equals to mod B minus mod A intersection B. So what is mod B? 40 minus 15 is equals to 25. So only application programmers are equals to 25. See, all the results can be shown in the Venn diagram. See, this is set A, this is set B. Only, only, only system programmers. How many? 15. Only application programmers. How many? 25. A intersection B 15. So total 13, 15 plus 15, 30, 30 plus 25. So total 55 we got. Okay. See, this is first problem. Now coming to the second problem. In a class of 52 students, 30 are studying C++. In a class of 52 students, 30 are studying C++, 28 are studying MFCS, and 13 are studying both languages. So, in a class of 52 students, so what are the total strength of the class? Total strength of the class, this is 52. In the 52, C++ only studying. 30 are studying C++ and 28 are studying MFCS and 13 are studying both the languages. Both the languages. And that means both the languages means C++ he can study and as well as MFCS also the person can study. How many in this class are studying at least one of these languages? At least one means actually how many subjects? Two subjects only. At least means minimum one subject. Minimum one subject means minimum at least means at least either of these two languages, at least MFCS or at least C++ or both can do. Okay, so what they have given from the question, class of total students, that means total students in the class, total students in the class that equals to mod u equals to 52. Okay, now studying C++, set A, let A be the set of members who studying C++, studying C++, that equals to mod A equals to 30, studying MFCS, that is mod B. Take the set B who are studying MFCS. So that is mod B equals to 28. Okay. Now 13 members are studying both the languages. Studying both. That means C++ and MFCS. That equals to A intersection, mod A intersection B. A intersection B means set, mod means the number of elements. So mod A intersection B equals to 13. What the question is asking, how many in the class are studying at least one of these? At least one of these means at least studying C++ or are studying MFCS or both. So that means A union B. What is A union B? In the set, A union B means the element which belongs to either A, okay, or A or B or B or both both the sets A and B, okay, are both. So that means A union B. So we have to calculate A union B. So now we have to find A union B equals to what? So by the principle of inclusion and exclusion of two sets, by the principle of inclusion and exclusion, what do we know? Mod A union B equals to mod A plus mod B minus mod A intersection B. So this equals to 30 plus 28 minus 30. So mod A union B equals to, now calculate this one, 58 minus 13, this is 45. Okay. So therefore the number of students are studying at least one of the language, one of the subject or language, anything, one of the subject or study, one of the subject. Okay, that equals to 45 members. Now second point, how many are studying neither of these languages? Neither of these languages, that means the number of students who are not studying C++ or MFCS. The number of students who are not studying C++ and not studying MFCS. So they don't study both the languages. Okay. So that means A union B bar. Okay. A union B. In the set A union B, what are the members we have in the set A union B? A union B represent that at least one subject. Okay. So the complement of A union B means neither. Okay. So A union B. So A union B means mod U minus mod A union B. Okay. From the total set. So from the total set, how many are studying at least one language? If you subtract, then we get the number of students who are not studying either of the language, either of the subject. So mod U means 52 minus mod A union B equals to 45. So 7. 7 members don't study either of these language. Okay. So 7 members are not studying either of these languages. This is second problem. Now, third question. If A, comma B, comma C are three finite sets, then prove that mod A minus B minus C equals to mod A minus mod A intersection B minus mod A intersection C plus mod A intersection B intersection C. Okay. So, we know that principle of inclusion and exclusion for three sets. So just I am going to write the formula for A mod A union B union C equals to mod A plus mod B plus mod C minus mod A intersection B minus mod A intersection C minus mod B intersection C plus mod A intersection B intersection C. This is principle of inclusion and exclusion for three sets. But here asking that mod A minus B minus C. Okay. So now suppose let A comma B comma C are three sets by Venn diagram representation. This is A, this is B, suppose I am taking A is this one, B is this one, C is this one. So let A comma B comma C are finite sets. A minus B minus C is the set of elements A minus B minus C. See, observe A minus B minus C. From the set A, we are subtracting B and we are subtracting C. From the set A, we are subtracting B and we are subtracting C. Okay. We are subtracting from the, so this is what this is This is total A union. This is total A union B union C. This is total A union B union C. In the A union B union C, if you subtract B union C, B union C, we want this one only. A minus B minus C. A minus B minus C means from the set A, we have to subtract B and we are subtracting A. This means only this one we have to find. Only this one you have to calculate. Okay. To instead of finding this one from A union B union C, if you subtract B union C, this is B union C, right? Okay. From total A union B union C, if you subtract B union C, we get this one. Okay. I hope everyone understood. So A minus B minus C is the set of elements that belongs to A, but not B or C. Okay. So from the Venn diagram, from the Venn diagram, mod A minus B minus C equals to mod A union B union C minus mod B union C. So you expand this one by using inclusion and exclusion of 3 sets. You expand this one by inclusion and exclusion of 2 sets. What is A union B union C? Mod A plus mod B plus mod C minus mod A intersection B minus mod A intersection C minus mod B intersection C plus mod A intersection B intersection C. What is mod B union C? Inclusion and exclusion of 2 sets. So mod B plus mod C minus mod B intersection C. So just I am going to expand this one. Mod A minus B minus C equals to mod A plus mod B plus mod C minus mod A intersection B minus mod A intersection A intersection C minus mod B intersection C plus mod A intersection B intersection C. This is for A union B union C. Now next, minus of mod B union C. Mod B plus mod C minus mod B intersection C. Now minus B plus C minus C minus mod B intersection C, minus into minus plus. So what you get? Mod A minus B minus C equals to mod A minus mod A intersection B minus mod A intersection C plus mod A intersection B intersection C. Okay. So I hope everyone understood. You have to remember this formula, because when we are solving the problem, sometimes they ask only A. From the sets of 3 sets, only set A values they can ask. So only A means mod A minus B minus C equals to mod A minus mod A intersection B minus mod A intersection C plus A intersection B intersection C. Okay. So if you like this video, subscribe and give like. Thank you.